Our last problem, number 5, is the exact same thing, except that they're going to ask you to do a little bit more work in arranging them. So plus 1, plus 2, plus 3, plus or minus 4, minus 3, minus 2, and minus 1 there. So the first thing we're going to do is look at their charges. So what do we have here for these guys? We've got calcium, beryllium, potassium, and calcium. So calcium, beryllium, potassium, and calcium. So that's a plus 2, plus 2, plus 1, and plus 2. Now let's go ahead and look at the anionic side of things. We got oxygen, oxygen, chlorine, and chlorine. So oxygen, oxygen, chlorine, and chlorine. So I've got a negative 2, a negative 2, a negative 1, and a negative 1 over here. So it's pretty obvious which of these guys is the weakest of them, because the potassium chloride has the weakest cationic charge and the weakest anionic charge. So potassium chloride is going to be weaker than anything else. This guy is the weakest because he's got the weakest charges. And again, they want them in order of largest to smallest. So KCl should be the weakest of them. All right. Our next weakest should be pretty obvious. That should be the calcium chloride, because it's a plus 2 and a minus 1. Now we are comparing the calcium oxide and the beryllium oxide. They are slightly more difficult to compare because they're both plus 2 and minus 2 here. So now what we have to do is we have to compare their sizes. Well, the oxygen is the same in both of these examples, so I'm going to ignore that. So really what we're doing is we're comparing calcium and beryllium. So here they are, calcium and beryllium. This guy here is a small ion, and so it should be the strongest. This guy here is a large ion, and it should be the weakest. So the strongest of these bunches should be the beryllium oxide, because it's a plus 2 minus 2, but it's a small ion. The next one should be the calcium oxide, because it's a plus 2 minus 2, but it's a larger ion.